Dear students, in the previous lecture we have seen the introduction of partial differential equation. In that we have seen what is partial differential equation, then what are the notations of partial differentiation with respect to x, with respect to y, and second partial derivative, then with respect to x, and second partial derivative with respect to y, then mixed partial derivative, that is the values of p, q, r, s and t we have seen in the previous lecture. And as I told in the previous session that this partial differential equation, so in this we have formation of PDE of two kind. First kind is formation of PDE by eliminating the arbitrary constant, and second one is formation of PDE by eliminating the arbitrary function. So firstly we will see today in this lecture formation of PDE by eliminating the arbitrary constant. So this formation of PD means arbitrary constants, means constants may be alphabets usually here, or maybe any constant numbers we have to eliminate. So for example, in general, I will consider the function f of x, y, z, a and b equal to 0. Here z is a function of x and y, this z is a function of x and y, and this a and b are constant. So to eliminate this a and b for the function z of the two variable x and y, we have to differentiate this partial differential equation with respect to x as well as with respect to y. After differentiating, we have to see that whether the given differential equation having that partial differential equation is eliminated with the arbitrary constant a or b or no. So if two arbitrary constants are there, so we have to differentiate with respect to two variable what they will give. So here it is x and y, we have to differentiate with respect to x and y, and we have to eliminate by any of the concept, and in detail we'll see by using one of the example. So if only two arbitrary constants are there, so we have to differentiate with respect to x and y. For suppose if the arbitrary, so remember here we have two arbitrary constants and two variable, so therefore only first order partial differential equation is possible. If suppose if number of arbitrary constants are more than number of independent variables, so here x and y are independent variables. If so for example here only x and y are the two independent variable, but here you getting a, b, c, d, means constants are more than 2 and independent variables are only 2. So at that time we need to go for what here, higher order partial differential derivatives. That is, so if it is two independent variable, two constants, we need to find the value of p and q. Remember, okay, what is p? It is dou z by dou x, and what is q? It is dou z by dou y. But if it is two independent variable but constants are more than 2, in that case we need to work out for r, s and t as well as, okay. So these all will see by using one of the example, and it will be clear. So if the number of arbitrary constants are more, then the number of independent variables, we need to appropriate the number of partial derivatives of the second order and higher order also. Fine. Now we'll see the examples based on this formation of PDE by eliminating the arbitrary constant. Now the problems based on eliminating the arbitrary constant. So I have taken the first example. Form the PDE, that is partial differential equation, by eliminating the arbitrary constant of the equation z is equal to x plus a, y plus b. So given z is equal to x plus a, y plus b. So this differential, this is a one of the equation they have given. So in this z is a dependent and x and y are two independent variables. We have two independent variables, we have two constants. So therefore differentiate partially with respect to x and y. This given equation we need to differentiate partially with respect to x first as well as y. So first we'll differentiate this partially with respect to x. So partial differential equation of this given equation with respect to x is dou z by dou x. Okay, with respect to x I am writing first equal to. So we need to differentiate this partially with respect to x. So what happens here? So x plus y. So here two brackets in multiplication. So here we can see that y plus b is purely constant. Fine, this is a purely constant. So here we need to differentiate this. So differentiation of x with respect to x is what here? 1 plus differentiation of a with respect to x, which is constant, 0. So why we are not made 0? Because this, for this bracket it is multiplied. So this is purely constant for the function x. So at that time we need to keep this one as it is. Only we have to differentiate this bracket with respect to x partially. So while making this derivative of this bracket partially with respect to x is what here? 1 and 0. So on simplification, and we know that notationally dou z by dou x is nothing but p is equal to, that is dou z by dou x is equal to 1 plus 0 is 1, 1 into this bracket is y plus b. So with respect to x we got this result. Now differentiate partially with respect to y we have to check now for the given equation, that is dou z by dou y is equal to, now we have two brackets. Now with respect to y means this x plus a is purely constant, will keep as it is. We have to differentiate this partially with respect to y. So partial derivative of y with respect to y is 1 plus b is purely constant with respect to y, 0. So therefore dou z by dou y is nothing but q is equal to dou z by dou y is equal to 1 plus 0 is 1, 1 into this bracket is x plus a. Now, so with the help of this we need to conclude the result. So here we need to substitute the value of p and q, or dou z by dou, these all here. So q equation number 1 for the given equation. So remember, on right hand side, see, this is not possible for all the questions. Every problem having different ways to get the result of partial differential equation. Main task of this problem is we need to eliminate this, means we don't want this a and b in this equation. So we know that y plus b, I will give this as 2 and 3. So I will say that substitute 2 and 3 in 1. So what is 2 and 3? So remember, y plus b is nothing but what here? P, or else you can consider dou z by dou x also. So y plus b, so in this equation y plus b will replace p, and equation 3 x plus a will replace as what here? Q. So therefore equation 1 becomes z is equal to pq, because p is nothing but y plus b and q is nothing but x plus a. So this is a required required PDE. So in this way, so in this you can observe here, so there is a no arbitrary constants. So which are the arbitrary constants here? A and B are the arbitrary constants in the given question. Okay, so we see the next question.